Hey, my name's Harif Mansour from Physics 2111, Section NO2, and today I'm going to be teaching you guys about the physics of dropping an object to the floor. So in this video, I will be comparing my experiment, which I imported into this program, Tracker, versus two models that I created with the computer programming software Python. One model is with drag and one model is without drag. So let's start. So I had my friend Carlos drop a paper ball to the floor, and I found the center point of mass at each frame taken, which is shown by these red dots. The mass of the paper ball weighed about 5 grams, and the whole duration it took about 5 seconds to hit the ground. So first I created the model with no drag, and here I had added this equation. It's the biggest thing that I changed to the Python code besides adding my parameters, such as t is less than half a second, gravity is 9.8, my initial position and whatnot, was the formula W equals negative ball dot m times g times j hat. And let's see what this model produces. I then created my model with drag, and I of course included my initial conditions, and with drag I had to add another equation, which right here I called FD, and put in the equation for drag, which in this case was negative b times ball.vel. And in this case, to help me find b, I kind of used the method of just go until you get it right to find the value of b. So in this case, I'd run the code over and over again and just change the value of b until my final position was the same as my final position for the experiment. So let's run the model.
You just said really. Yeah, let me see model.
So I can compare my experiment to my model position with drag and my model position without drag. And as you can see, my model position without drag is far different than my model position with drag in my experimental model. So as you can see by the chart, the model position with drag and the experimental model both go in a straight line, whereas the model position without drag curves downward. This is because the model position without drag picks up acceleration, whereas the model position with drag and the experimental model do not. This is because of terminal velocity, and this is where the acceleration that would be caused by gravity is cancelled out by the drag force. What if I threw the paper ball downward? If I threw the paper ball downward, then initially this line would curve way down, but then as the drag force canceled out the force of gravity, the acceleration would slowly come downward and reach not terminal, but the acceleration would be a lot less than it is over here. So in this time versus velocity chart, it's clear to see that the acceleration that is being picked up with the model position without drag is very great compared to the acceleration, if there is any, for the model position with drag and the experiment.